Assalamu alaikum students. In the last lecture, we were discussing about the IP addressing and subnetting at the layer 3. Okay, so today we will study about the routing protocols, and we will see here what are the different approaches that are used for routing at the network layer. Basically, we will discuss the two approaches, that is the distance vector and the link state routing protocols. Okay, so first of all, we will see here what is routing. The basic problem of routing is to find the lowest cost path between the two nodes. As we know that routing is basically finding the best path. So how the routers maintain their routing tables, or how they find the best path between the two nodes, they try to find the lowest cost path between the two nodes. Okay, this can be done statically. For example, if there is a very short small network, then it can calculate all the shortest paths and load them into the, or save them into a storage of the each router. Okay, but this approach can be is a very static approach. For example, in this case, if the network details, or all the paths details of all the paths to the other nodes are saved in a memory, then in case if there is a link failure or a node failure, or there is addition of any new node or link, then in this case these values, or these shortest paths values cannot be changed. Okay, so this means a static approach cannot be used for all type of networks. Okay, this can only be used for the very small networks. Okay, but in case we have a large network, or we are talking about the internet, then we need a distributed and dynamic protocols. Okay, so there are two main classes of protocols, that is a distance vector and the link state protocols. Okay, so we will discuss both type of the protocols. First we will discuss about the distance vector protocols. As we discussed, there are two main approaches, that is the distance vector protocols and the link state protocols. Now the question is where these two type of the protocols are used. These two protocols are used in the different type of the network. For example, there is an intra-domain routing. For example, this is used for the small and medium networks. Okay, these type of the network is a small and medium networks which are which are using the intra-domain routing. These protocols basically use the distance vector protocols. Okay, the examples are routing information protocol, or the open shortest path first, that is OSPF. This means the RIP and OSPF are mainly used for the small and medium networks, and they're used in the intra-domain routing. Now, what is the domain? Basically, the routing domain is an internetwork in which all the routers are under the same administrative control. Okay, so this means if all the networks or all the routers, they are under the same administrative control, this means we are talking about the intra-domain routing. And in such networks, we use the distance vector protocols, or the examples are RIP and the shortest, or OSPF. But if there's an inter-domain routing, that is for the large and global networks, in this case usually the link state protocols are used, which is the example is BGP. Okay, so first of all we will discuss about the distance vector protocol. Okay, what is a distance vector protocol? In the distance vector protocol, for example, there are multiple nodes, and that is routers. Then each node basically construct a vector containing the distance to all other nodes. And what is the distance? This is actually called the cost to reach to the other nodes. Okay, so here the cost is actually calculated as the distance between the two nodes. Okay, so first of all, each node construct or calculates the distance to the other nodes, and then it distributes this value to its immediate neighbors. This means it shares the information with the other nodes. Okay, so in this case, in the distance vector protocol, the algorithm which is used is usually called the distributed Bellman-Ford algorithm. So before discussing this algorithm, we will assume that each node knows the cost of each link to its direct neighbor, and cost can be configured on many basis, but usually here we calculate the cost on the basis of the usually the cost can be calculated on the basis of the data rate, delay, packet loss rate, or estimating or can be estimated according to other metrics, but here we will calculate as the number of hops. Okay, so we are actually calculating the cost to the immediate neighbors, and in case there is a link down between the two nodes, then we will consider that cost as the infinite cost. Okay. Okay, so first we will see what are the basic steps in the distributed Bellman-Ford algorithm. First of all, each router starts with a vector of distance to all the directly attached networks. Okay, then each router advertises its current vector, that is the cost calculated to the immediate neighbor, to its all the neighboring nodes. This means first it calculates the cost to the directly attached network, that is the vector of distances, and then it share this information with all the neighboring routers. And upon receiving the vectors from all of its neighbors, the routers basically computes its own distance to the each neighbor. Okay, that is mean the immediate neighbors. Then for each network, as there are many networks, this means then after these steps, then for each network, router finds that neighbor who is closer to X than any other neighbor. This means after the immediate neighbor, then it calculates that what is the distance between the other network, that is for example the network X. Then for all the network X, routers basically find the neighbors who is closer to X than any other neighbors. There might be a case that there are two neighbors who are closer or who have the information about the network X, but the router will find the neighbor who is closer to X than any other neighbor. Okay, and then the router will update its cost to X, and after doing this, for all the X, this means for all the network, the router will go to the send step. Okay. Basically, in distance vector protocols, each node, that is the router, they maintains a routing table, and they actually save three type of the values. First one is the destination, then the cost to this destination, and then the next hop. What is the next hop? Next hop is basically that router through which it can reach to the destination. Okay. And these steps are basically, these type of the information is maintained by exchanging the updates with the directly connected neighbors. Okay, this table is not a static table. Table is periodically updated. How this table is updated again and again? By exchanging the updates with the directly connected neighbors. And these updates are basically exchanged periodically, as well as they are triggered updates. Okay, so what is the periodically? This means these updates are basically the routers update their routing table after the equal intervals of time. For example, we can say after 30 seconds or after 1 minute or 5 minutes. Okay, and the triggered updates are, this means if there is a node failure, or there is an other message from some neighbor. Okay, so in this case, these are basically triggered by getting the update. Okay, so this means there are two type of the updates, that is first one is the periodically, and second is the triggered update. Whenever they receive the update from another router, it causes to change its routing table. Okay, in case this is a triggered update, whenever the router will receive any update from the other routers, or then it will change its routing table. This means the values can be changed on this basis. Okay, so this means this routing table is a dynamic routing table which is continuously updated. Okay. Now we will consider an example. For example, this is a basic graph of the different nodes. This is a graph of the different nodes and links between the different routers. Okay, so we will calculate that how each router will maintain its routing table according to the Bellman-Ford algorithm. Okay, so this is a global view, but we will first of all see, it's better to see the routing table of each node. For example, in this graph we can see that there are A node, B node, C, D, E, F, and G, and there are multiple nodes, and some nodes are directly connected, some nodes are connected by or via two other nodes. Okay, so how they will actually maintain their routing table? So we will see what is the basic structure of the routing table. As we have said that they maintain basically three values, that is the destination, then cost, and next hop. So first of all, we will see the routing table of the node A. We can see this is the same graph. we can see that A is directly connected to B, C, E and F. Okay, so we will see if the destination for A node, okay, right now we are actually looking at the routing table for node A, that is the router A, and we will, this is the router A, and we will see how the routing table for node A is maintained. Okay, so this is the destination and this is the cost for the destination and this is the next hop. Okay, if their destination is B, then the cost is 1. Okay, this is directly connected, so this is the cost is 1 and the next hop is B. This means it can reach to B through B, via B. Okay, so the next hop to reach to the node B, it has to move through B. Okay, so this means next hop is B. Similarly to node C, it can reach to destination C with the cost 1 and the next hop will be C. For D, it's okay, for D, as the D node is not directly connected, so this means for D, the cost is infinity, okay? Because it is not directly connected, it will update its information after the multiple steps. But for the first step, the D is infinity, the cost is infinity because it is not directly connected and it can, and there's no next hop, okay? For E, as E is directly connected, so the destination is D, the cost is 1 and the next hop is E, okay? For F, cost is 1 and the next hop is F. Similarly for G, as it is not directly connected to G, this means the cost is infinity and there's no next hop. Similarly, we can check the routing tables of all the nodes for B, C, D, E and F and G. Okay, so we will see this is the routing table for B, as this is the node B and it is directly connected to only 2 nodes. We can see it is directly connected to only node A and C. Okay, if we are talking about B, so we can see all the distance or the cost to the all the other nodes except A and C, the distance is, the cost is infinity. Okay, similarly if we talk about the node C, it is directly connected to 3 nodes, so this is the cost for 3 nodes and all the other nodes are infinity. For D, we can see it is directly connected to 2 nodes, C and G. Okay, so we can easily see that D is directly connected to 2 nodes, that is C and G. So it has the cost for C and G, but all the cost for all the other nodes are infinity. Okay. For E is only connected to A, so it has the cost for A, that is A and next hop is A, but all the other distances are infinity. For F, it is directly connected to 2 nodes, that is A and G, and the rest of the nodes are infinity to F. And for G, it is directly connected to F and D, that is F and D, that is D and F, okay? And all the other nodes are infinity to this node, okay? So what is the first step? All the nodes know the cost or the distance to its immediate neighbor in this step. In the next step, these nodes will basically share their information or they share their updated routing tables to the other nodes. Okay, then we will see how this routing table will be updated. Okay, first of all, we will underline all the nodes that have the cost that is equal to infinity in the last slides. Okay, so then we will see how they will update their information after exchanging the information with the immediate neighbors. Okay, so let's say the cost of the D was infinity. For A, the cost of D was infinity, G was infinity. Okay, these two were infinity. Similarly for B, only two nodes were known, but rest of the nodes were infinity. And similarly for C, only three nodes were known, that is B, A and D, and the rest of the nodes were infinity. We can see in the last slide that these nodes were basically infinity. Okay, so first we will only calculate, or we will see how these tables are basically updated. Okay, according to the steps that are followed by the Bellman-Ford algorithm, in the first update, basically all the nodes share the information with their immediate neighbors. For example, the A has the information of B, C, and D. It will share the information with B, C, and D. Sorry, not D, B, C, E, and F. Okay, as these nodes were known to A, so it would share the information with all these four nodes. Okay, and all these four nodes will get to know that A has the information of all these nodes. Okay, so what will happen? For example, the D was unknown. Okay, and similarly the G was unknown. Okay, why? Because they were not the immediate neighbors of the node A. Okay, first of all, see how we will calculate the cost of D. Okay, it was infinity for A because it was not the direct or the immediate neighbor of A. When it will share the information with C, okay, and C will share the information with A, C will tell this is the information of the C, and C have the information of D. That is, it is the cost of the D is 1, and it can be reached by the next hop as a D. Okay, when the information will be shared, this information of C will be shared with A. Now A can calculate the cost of D. Okay, because the cost of C was 1, and the C knows that the cost to D is 1. So this means now the cost of D is 2, and this means the node A can reach to the destination D with the cost of 2 by using the next hop C. Okay, this means A can reach to D by using C as a next hop, and the cost is 1 plus 1. That is the cost that is calculated by the C and the cost to the C. Okay, so similarly we can calculate the G. When G will A has not the information of G. Why? Because it was not the immediate neighbor of A, but it was the immediate neighbor of F. Okay, A knows about the F, but F was the immediate neighbor of G. So according to F, the cost of the G was 1 via G. Okay, and similarly when the A will try to calculate, when the F will share the information with A in the first update, then A will get to know that it can reach to node G, it can reach to destination G with cost 2. The cost to G, the cost to F is 1, and plus cost to G is 1. So this means the total cost will be equal to 2, and it can be reached via F. So this is how all the routing tables of the node A, B, C, D, F, and G will be updated. Okay, you can see the nodes which were infinity in the initial step. Now they have updated their information that for B now, let's erase all the. You can see that now the nodes which were infinity. For B, the D was infinity, but now the B can reach to D with the cost of D with the next hop C. Similarly, it can now reach to E via via A. Okay, now the B can reach to E via A. and the cost will become 2. Okay, so this is how all the routing tables will be updated, but still there are some nodes which are infinity to the other nodes. For example, let's see, let's consider the E node. E node now knows the all the nodes which are actually the immediate neighbors of A. For example, E can now reach to all the nodes which are the immediate neighbors of A. So it can reach to the other nodes. First of all, it was the immediate neighbor of A, so it was only known about the cost of A, that is through A. But now when A will share the information with E, that it has the information of node C, node E and node F, when it will share the information with node E, now E can reach to these nodes, that is the immediate neighbors of A, B, C and F. Okay, the immediate neighbors of A are B, C and F. When A will share this information with E, now E will update its information that now it can reach to the destination B with the cost B with the next hop A. It can reach to C with the cost 2 with, and the next hop will be A because it will reach to C via A. Okay, and it will update the information of F that the cost is F, destination sorry, the destination is F, the cost is 2 and the next hop is A. It will reach to the F via A. But still there are some nodes which are unreachable because D is not reachable, FG is not reachable. Okay, so in the next update, these tables will be updated. How? When these nodes will exchange the information with A, as they have exchanged the information with A in this update, first update, and when on the next step, when again A will share the information with these nodes, then it can calculate the information, or it can calculate the cost to these nodes which are actually far away from these nodes. Okay, so next let's move to the second update. We can see that D was infinity for E. Similarly, the G was infinity to A. As in the first update, the A was updated. We can see it has updated that the distance to D and G is 2. Okay, so when this information will be shared in the second update to E, now it can calculate that G and D, they have the cost of 2 for A. So when E will reach to these costs, sorry, when in the second update, when the E will try to reach to these nodes, via, okay, when they're talking about a destination D and G, and E can reach to these destination via A, and A has the cost for these two nodes, that is 2, and similarly for D as well. Okay, so when E will add their information, it will add the 1 which is the cost to A, and the cost, and A has the cost 2 to reach the destination D, so total cost will be 3, and similarly in this case the cost will be 3, and it will move to these nodes via A. So this is how the E will update the information of all these nodes. Similarly, we can see in the last update, that was the first update, some other nodes were unreachable. For example, for D, the E was unreachable. Okay, now we can see, and now it's 3. Why? Because the cost of C was the cost of for D, the cost of E was, we can see for D, let's erase this information, then we will calculate for, okay, now we are talking about the node D, and this is the second update. Okay, we have known that in the last update for D, the E was unreachable. Okay, now we know that E can be reached through C. Okay, if we are talking about node D, We are talking about node D, how it can reach to E. It can reach to node C with the cost of 1. And for C, the cost of E, destination was E and the cost was 2. Okay, so for C, the cost of E was 2 via A. When D will try to reach to the destination E, it will try to reach through via A, via C, and it will add the cost of C. That is 2 1 1. 2 plus 1 is 3. So this means now the D node can reach to E by following this path. This means the next hop will be C. We can see that D has added the information. The destination E can be reached at the cost of 3 and the next hop will be C. This is the path. Okay, so this is how in the second update all the information after getting the information that was updated in the first update, when in the second update that information will be shared with the immediate neighbors, then the nodes which were infinity, still infinity in the first update, now they can also be updated. Okay, so this is how the all the information will be added of all the nodes in each node. Okay, for router A has now the information on the cost of all the other nodes. Similarly, the B has the cost of all the other nodes, and C has all the cost of other nodes. Similarly, all the nodes can now update their information. Okay, so this is the basically the global view of all the nodes. We can see now if there's a node A and the destination nodes are this, we can see how these tables are collectively assembled in a global view of each node. Basically, the nodes or the round tables are maintained. They use a distributed approach. Each router maintains its own table. But for us, this is just a global view that what is the distance to the each destination for every node. We can see that for node A, these are the cost for the every destination. And similarly for node B, this is the cost for every destination. Okay. Okay, in the next lecture, we will discuss the same protocol, but we will see if there's a link failure, how these route tables are basically maintained, how the Bellman, how these routers basically, according to the Bellman Ford algorithm, how they update their routing tables. Okay, so Allah Hafiz.